Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Indicators. Okay, so in today's class, we are going to some terms related to propagation of sound, or rather, you can also say to the related to sound itself. Okay, so what are those terms? Let us discuss. In the previous class, we have discussed how sound is produced, how sound propagates, okay, and while we have been discussing how sound propagates, we have discussed about the region of compression, the region where the air molecules get compressed, and the region of rarefaction where the air molecules get move away from each other. That is a region of relaxed zone is created, okay. So we have already discussed this. Today we are going to discuss the terms related to sound wave, okay. So take out your pen and copy, make heading terms related to sound wave. Okay, first term that we are going to discuss is amplitude. So first term that you must know about is amplitude. So what is amplitude? What is amplitude? Simply see, when a body is vibrating, see, if I consider this pen is vibrating like this to and fro, it is moving to and fro, okay, left right, so it's a to and fro motion. So in this case, to and fro motion, the initial position of this pen, when the pen was at rest, this position of the pen is called the mean position, okay. So I think what is mean position is clear. When the vibrating object, before it starts vibrating, when it is at rest, that position of that object is called the mean position. Now when the pen starts vibrating, that is moves to and fro, it certainly in this case goes a certain stretch, up to a certain stage it goes to right and then comes back to the mean position, and then again at a certain stretch goes to the left. So this maximum displacement of this particle of this pen from its mean position to the either left or right, okay, or you can also say when it is moving up and down. So the maximum displacement of this pen in the upward direction from the mean position, or the maximum displacement of the pen in the down direction from its mean position, can be regarded as the amplitude, okay. So I think amplitude is concept is clear. So it can be written in short as maximum displacement of a vibrating body from its mean position. So this is amplitude, okay. So maximum displacement of body from its mean position is called the amplitude. Now what is amplitude? We are saying that it's a maximum displacement. So if I consider what is the SI unit of amplitude, can you say it? Yes, definitely. As it is, amplitude is nothing but displacement. So we have learned already that the SI unit of displacement is meter. So the SI unit of amplitude is also meter. So SI unit is meter. But generally what happens when an object or when a body is vibrating, does it move a large distance to and fro? No, the pen is just moving like this, okay. Many times the vibration is much smaller than that also. So the vibration sometimes is very small if we say it in terms of meter. That is why, although SI unit is the commonly used unit for vibration for the amplitude, however we also denote amplitude sometimes in centimeter. Also for very small vibrations of very small magnitude, very small amplitude, we can also use units like Armstrong. So if I say what are the other units, okay, what are the other units? So other units used commonly are centimeter, Armstrong. So this is a symbol for Armstrong. So these are the commonly used units for amplitude. Generally meter is not used because in most of the cases the vibration, the amplitude is very small, hence these units are used. Okay. Now, second, after amplitude comes the second point is the time period. Okay, is the time period. So, what is time period? See, when the vibration takes place, it takes certain time to complete one vibration. Now, what do you mean by one complete vibration? If I consider this pen moving left and right, so it starts from the mean position, moves to the extreme right, comes back to the mean position, again moves to the extreme left, and then it comes back to its mean position. This is called one complete vibration. Okay, so it starts from its mean position and comes back to its mean position after one vibration. So this takes a certain amount of time. This time that the vibrating body takes to complete one vibration, or rather you can say also one oscillation. If I say consider pendulum, the pendulum just swings like this. Okay, left right like this. So this pendulum starts from mean position, goes to the extreme right, comes back to the mean position, goes to the extreme left, and then again comes back to the mean position. This is called one oscillation of the pendulum. So the time taken to complete one vibration by the vibrating body is called the time period. So time period can be defined as time taken to complete one vibration is regarded as the time period, and generally time period is denoted by the letter capital T. Okay, remember this is denoted by the letter capital T. So this is time period. Now what do you think will be the SI unit for time period? Obviously time period is the time taken. So it's what it is? It is time. The quantity is actually time. So the SI unit of time period is seconds. Okay, is second. Fine. Now the third term that we need to know is the frequency. So what is the third term? The third term is frequency. So what is frequency? Think of it like this, that when a body is vibrating, say two bodies are vibrating, if I just try to compare which body is vibrating faster, then we will need to think of which body is making more vibrations in a say particular time, isn't it? So if I say that I consider the time interval for comparison to be 1 second, and then say okay, one body is vibrating in such a way that it completes 5 vibrations in 1 second. Okay, and say if another body completes say 7 vibrations in 1 second, then can we compare which body is vibrating faster and which body is vibrating slower? Yes, definitely. So if I compare in that case, then we can say that the second body, which was vibrating 7 times a second, is vibrating more faster. So that can be this number of vibrations. When you are thinking of the number of vibrations in a second, taking in a second, that is regarded as the frequency. So frequency can be defined as number of vibrations per second is regarded as the frequency. So if I think of, and frequency is generally denoted by the letter small f. Okay. So if you consider that what can be the SI unit for frequency, can you think of? Yes, definitely. We are saying that number of vibrations per second. So basically it is the reciprocal of the time. Okay, how? We will be just explaining it just a second. So just write it down. SI unit of frequency is second inverse, or it can be also written as hertz. Okay, it is also denoted as hertz. Symbol is capital H, small z, hertz. Okay, so this is the frequency. Now can you just think of how frequency and time period can be related to each other? Just can you imagine how these two terms can be related to each other. Okay, so for that we are taking an example how the time period and frequency are related to each other. Okay, say if we say that if one vibration say takes 5 seconds, okay, so we are writing it on the board that one vibration takes 5 seconds, okay. Okay, so you are taking it, we are saying that one vibration takes 5 seconds, okay. Now what is this? This time taken to complete one vibration, this is nothing but the time period divided by letter capital T, isn't it? Yeah. So what is frequency? Is the number of vibrations in 1 second. So just write it in the other way. So in 5 seconds, number of vibrations completed is, so vibration completed is 1, okay. So if I say apply unitary method and say in 1 second the number of vibration completed is, it is 1 by 5. So what is this? This 1 by 5. This is basically the frequency, isn't it? Because we are saying the number of vibrations taken in 1 second. So it's 1 by 5. Okay, it is not a whole number, that is not the factor, but this is actually the frequency, number of vibrations per second. So can you just think that if you want to find out frequency from time period or from frequency you want to find out the time period, in both the cases what you do, you get a formula, simple formula, that either is a time period is the reciprocal of frequency T is equals to 1 by f, or you can also denote is that in this way, that frequency is the reciprocal of time period, f equals to 1 by t. So this is how frequency and time period are related. So as time period has a unit of seconds, so f is equals to 1 by t, then definitely frequency will have a unit of second inverse, or in other words is also regarded as hertz. Okay. So in today's class we will be stopping here. In the next class we will be discussing the other terms related to the vibration. Okay. So I hope you are understanding the lessons. If you have any query, please do mention it in the comment box. We will be happy to solve your problem. In the next class, please do study well. Thank you. Goodbye.